this tutorial, we're going to see how to blink an LED with STM32 microcontrollers. The hardware that I'm using in this tutorial is STM32 F103C86, the so-called Blue Pill ones. You can find them by this name, and ST-Link version 2 programmer. I use it in order to upload the code to my microcontroller. Softwares that are used in this tutorial: STM32 CubeMX. It is used for microcontroller setup. We'll see how we will use it. And a Keil Microvision 5. This is an IDE, and we use it for writing our codes and then upload it to our microcontrollers. So let's jump in. We click on STM32 CubeMX. You need to be a little bit patient because it may take a little bit while to set up this software. It's a bit heavy. Just a little patience is okay for this. Here we go. So, how to set up a project in STM32 CubeMX? And there are three ways in order to start it. Access to MCU selector. This is the one that I'm using. And access to both selectors. It is usually used when you are working with Nucleo boards, but in this case we're using Blue Pill, which is different from this one. So we choose access to my MCU selector and we use our specific microcontroller. Do you want to set your connection parameters now? I've done it some of it before, so I don't want to do it right now, so I click on remind me later. But if the first time that you're using STM32 CubeMX, you might need to click on yes. So commercial part number. Here you can search for your microcontroller, or you can navigate from here using the scroller, but I prefer to use the search engine, the built-in search engine in CubeMX, STM32F103C8 T6, the one that I already told you. Here it is. You can click it, and before you completely write it, it suggests you the microcontroller. Let's say you have a specific microcontroller and you use it frequently. If you click on this star, it is marked. And for later users, if you click on this, you could easily and pretty fast access it by clicking it. But right now we don't want to do this. Here is our microcontroller. By double clicking on it, our project will be made. So here is our microcontroller. The very first thing that we need to do is to set up the RCC, which is the clock of our microcontroller. On the boards there are crystals and we want to use it. So here has written high speed clock, and the short form of this phrase is HSE. We need to enable it via crystal ceramic resonators. These are the crystals that are mounted on our board, the Blue Pill board that we discussed already. And after that, we need GPIOs. We want to blink an LED, a general purpose output pin. On Blue Pill boards, an LED is connected to pin C13, which is denoted by PC13 in this video. By clicking on it, we have some options here: GPIO input, for example, or GPIO output, LLO, and etc. In this case, we're going to choose GPIO output. Why? Because we're connecting LED to this pin. The process data in microcontroller is sent to this pin, so it does something for us. So it is output. But for example, in most cases, sensors are input because they gather information from the environment and sends it to microcontroller. So, as I said, we're going to choose GPIO output here, as it has written here. And there's something that I would like to discuss, and that on Blue Pill's LED is connected to PC13 in a tricky manner. Why? I'll explain it to you. Let me search STM32 as written here F103 STM32 schematic, clicking on images. Yep, here it is. PC's an LED is connected to this and VCC, which is 3.3. In this case, the cathode pin of the LED is connected to PC13. So whenever the PC13 is 0, the LED is on. Why? Because the diode is on. Its cathode voltage is higher than its anode voltage. It is something around 0.3 with a little bit of voltage drop on this resistor, and here is the voltage here is 0, so the diode is on, and thus the LED is on. But whenever this pin is set to high or 1, and the diode is not on because its anode pin voltage is not higher than its cathode pin voltage. So the LED is off. That's why I said it's a little bit tricky. When the pin is set to high, LED is off. When it is 0, the LED is on. I hope this tip will be useful for you in future cases. And that's it. Analog, we have ADCs, analog to digital converter. An example for their usage is sensors. When sensors gather information from the environment, it is analog. For example, 5 volt, 3.3 volt. And this voltage needs to be converted to digital numbers. So they do this for the microcontroller, timers, and connectivities were discussed in future videos. CAD, I2C, USART, USB, etc., and other things. But we don't want to work them at the moment. And there is a tip I want to say and discuss here. Let's say unintentionally you click on a pin and set it to, for example, I don't know, GPIO interrupt. You did it unintentionally, so you want to reset it to its initial value. Again, click on it and reset state. Done. Its functionality is reset and doesn't do anything for you. And there is nothing more that I would like to discuss here, so let's go to configuration. Yep, here it is. As you can see here and in datasheet, the maximum frequency of this microcontroller is 72 megahertz. You have several options which crystal want to use: internal, external, low speed, high speed. But for this purpose, it really doesn't matter which one you want to use. So let's use just the max speed. Let's call 72 megahertz. Oh, there's a warning. No solution found using the current selected sources. Do you want to use other sources? It's the program is capable of changing the man by itself, so it could provide a 72 megahertz frequency for you. By clicking OK, this is what is going to happen. So our clock is just fine. The most important thing here is APP2 because our LED is connected to this bus. In later videos, we would work with reference manual and datasheet, and we would see which pin and which functions are connected to which buses. But for now, it's enough just to do this. Let's go to Project Manager tab. You need to specify a name for your project. Let's call it Blink underscore LED. Project location. Let me see this. You could save it wherever you want on your machine. I'm just choosing my preferred location. Open. It's just fine. And application structure, we don't need to change it. Toolchain folders, there's nothing that we want to choose. And toolchain or IDE, as I said in the beginning, we're going to use Keil Microvision 5, and this is that software MDKR. So we choose it. There are other programs you could use it. This is IAR Workbench. Many people work with this IDE, and also many people work with this MDKR. And there's an STM specific IDE which is called STM32 Cube IDE. I myself prefer Keil, and it is pretty common in industry and many people use it, and this is so popular. So let's click it. The minimal version, for example, the Keil should be at least a version to be able to run your program. So let's see what is the version of our own Keil. It comes up pretty fast. You don't need to wait so much. Help. The microvision that I'm using is version 5.38. So let's go back here. So it works just totally fine with 32. If you're using lower versions, you need to click different ones. But I just click this one and it works fine. Linker settings, you don't need to change anything here. Code generator, copy only the necessary library file. We don't want to make it big, which is unnecessary in these steps. And you don't need to change anything more. Advanced settings, no tools. And here's a interesting feature that STM has given us. You could use here if you're using a battery for your microcontrollers. You could do something in order to use less energy and expand your battery life. But at this moment, we're just connecting our microcontroller to my PC. So whenever you're done, just click on generate code. It takes a while. You need to be a little bit patient, but not so much. So you have three options. One is close. We don't want to use it right now. The other two is open the folder. It opens the location that you've created your project, and it includes the CubeMX file, the Keil Microvision file, and other dependencies. But for now, we just want to open the Keil Microvision itself and start coding. So click on Open Project. Well, the project is created for us. Let's expand this. Use the name of our project and expand this also. Application MDK arm. Let's see what's here. Startup STM32. We don't need to do anything in here, so we click on close. Minimize it. Application user. Oh, this is our main.c, and this is where we need to do most of our works. User code begins here. It is just something that the CubeMX itself prepares for you, and so includes. And there's something that you need to consider. For example, you can read here, user code begin includes. If you want to include something, you have to include it between begin and end. If you do otherwise, when you recompile it, rebuild it, it might delete your code. So be careful to write your specific and private codes between begin and ends that has been written and provided by the CubeMX code generator. So here's our int main. Our microcontroller starts reading codes and doing them exactly after this main here. Before this, there are just some includes and initializations. It also includes clock initializations and so on. But we need to our main functions here. Here the library has been initialized, system clock configuration has been done, and here's our while loop. A while loop. It is an infinite loop. If we write our code in between here, look, begin is here and end is here. So we have to write our codes somewhere around here. If we write it here, it is outside the while loop, and so we have to write it here But before we start writing code, let's see what else CubeMX code generator has done for us. It is again about configuring clock, and RCC is what I told you about before, crystal oscillators, PLL, and GPIO init. Here's the pins that we've configured in the CubeMX. GPIO pin 13, which our LED is connected to, and its modes, GPIO mode output, pull up and pull down, and initializing GPIO C, and etc. If whenever you wanted to know which pins have been initialized by the CubeMX code generator, you could come back here and see what codes have been generated by that. So this is our main C. This file here is related to interrupt, and we're working with HAL libraries that is provided here. Of course, you could write your own functions by referring to registers, and if you want to do so, of course, you have to refer to reference manual, which is released by ST company itself. But it's a hard work. However, it is so fun, and I suggest you to learn it if you're interested. But it's something that ST engineers have done before, and they've created libraries for you so you can use them and not go to register levels and bother yourself. It is much easier to use these libraries. So we want to blink our LED. What should we do? We have to toggle it. How can we toggle it? We need to have access to GPIOs. Look at the names. STM32 F1XX GPIO-C. It may be a good file to go to, and we see if we can find something related to toggling. So let's press Ctrl plus F. Just Ctrl F. You can find it, whatever you want by typing it. What I want to find is toggle. I want to toggle the pin and change its positions from on to off. So let's click on find toggle. It's just a comment, so we don't need it. Find next. Here it is. However, it has found something here, but our function is here. If I click on find next, of course it would find the desired function. I found it. How GPIO toggle pin. What it needs is GPIO type def. What does it mean? It has written GPIO X. You can write here GPIO C, GPIO A, and etc. And GPIO pin, for example, pin 13, pin 12, pin 1, pin 2, and etc. So we copy it and come back here and paste it. But we don't need this initialization. We just write GPIO. But the Keil itself suggests you some options, but if it was not here, by pressing Ctrl space, you can find it. It will suggest you the keywords. Here I want GPIO-C, double click, and I want pin 13. I guess I had to write GPIO pin. Here it suggests you what pin you want. GPIO pin 13. Yeah, that's it. For example, if the LED is on the on mode at first, it toggles it and it is off. But then I want it to wait for some seconds, or to speak in a pro mode. I want some delay. So again, let's search here. What can I find? Timers may be a good option, but HAL itself, we want some delay in HAL. So let's see if we can find it here. Again, I press Ctrl F and I search for delay. Let the search engine help us find next. No, these are not what we want. Find next. No, 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 next. HAL delay. So we found something. Generally, these functions that are started with this weak keyword are functions that you will copy them and paste them in your code in order to use them. And this is the body of this function, how it works. It works with HAL get tick. This function works in milliseconds, so we can understand that the input of this function is in milliseconds. So let's copy it, Control C, and again going to main C and paste it in the next line. We need to specify the delay time in milliseconds. Half a second is a good option, and I prefer this number, so I write 500 milliseconds. Of course, 1000 milliseconds is 1 second, so 500 milliseconds is half a second. That's just pretty simple. And after that, again, I want the pin to be toggled. So let's copy this piece of code again. Control C and Control V. Let's save the code and what we've written so far. Control S. And again, if it's off, I said it's an infinite loop. It again comes to the first line of this while loop, and again it is on without any delay, so our eye cannot detect it. So again we need a delay, so let's copy this and paste it here. Again, save it. So now we want to compile our code. To other words, turn this C code to zeros and one, things that computer can understand it. For compiling, it's enough to click on this rebuild. It is checking what we've written and what the CubeMX code generator has done. 0 errors, 0 warnings. Perfect. We've done everything pretty cool, and it is completely ready to be uploaded on our microcontroller. So let's see how we could connect our Blue Pill board to this ST-Link debugger via these female to female jumpers. You need to connect these pins to a specific pins here that are connected to our programmer via these jumpers. So you need a female to female jumpers. When I bought this ST-Link version 2 programmer, it was accompanied by these jumpers, and I didn't have to buy them individually. So let's see how we're going to do that. The pins that are responsible for programming our microcontroller on these Blue Pill boards are these pins. So let's see what are they. They are 3v3, which is a current way to demonstrate 3.3 volts. The next pin is SWIO or SWDIO, but because there isn't enough space here, it is common to show it by writing SWIO. And the next pin is SWCLK, and the last pin is GND. We have to find them one by one on our programmer. The first pin was 3.3 volts. We have to find it here. 3.3 volts. We have two 3.3 volts pins, and your pins number 7 and number 8. But how we could find them here? You could see a bold line next to GND. Well, this bold line indicates this port. So when you're looking at this diagram here in this view, it is as if you're looking at pins in this view. So when it says 3.3 3 volts is pin number 7 or 8, you could connect it to this pin. 1, 2, 3, 4, 5, 6, 7, or 8. It doesn't matter. So let's connect one of these jumpers to this pin. I prefer the jumper with white color to connect it to 3.3 volts. So it's pin number 7. Yeah. So I pick the white jumper and then I connect it to pin number 7. Yep. Done. What was the next pin? It was SWIO or SWDIO. They are the same, and because not enough space is provided there has written SWIO, but it is the same as SWDIO. It is pin number 4. If I look at this pin, it is 1, 2, 3, 4. This pin. The color that I prefer for SWDIO, of course, it is absolutely up to you. It is just personal preference. I pick the purple wire for SWDIO and I connect it to pin number 4. And second column and second row, SWDIO. What was the next pin? It was SWCLK. We need to find SWCLK. It is pin number 2. And I would prefer jumper with this color, and I connect it to pin number 4, the gray jumper. Pin number 2, connected to pin number 2. Yeah, as you can see, SWCLK. Gray pin, connected it to pin number 2. The last one was GND. And I connected, and I have to connect this blue jumper to GND. And the pins that provide GND are 5 or 6, it doesn't matter. I pick pin number 5. It is this one. As you can see, 5 near to this line, and here this part of the programmer. So I connect that. And finally, I have to connect these jumpers to my board. I had picked the white jumper for 3.3 and SWIO. I had picked the purple one, SWCLK, the gray one, and GND, the blue one. In this manner, I organize them and all at once I connect them to my blue pill. Yep, it is. Before uploading our program to our microcontroller, let's check some settings in Keil software. In order to do that, you have to click on these options for Toolkit, and its icon is shown here. So left click on it. And let's start from the first tab. In device tab, you're seeing the microcontroller that you're using. Here shows its pack and a link to download page of this pack. If it is the first time that you're programming your specific microcontroller using Keil, you need to download its pack for Keil in order to work properly. Otherwise, Keil won't work properly. How to do that, I will show you in a second. You need to go to this pack installer, and its icon is shown here. So left click on it, We need to wait until it reaches 100% and everything is loaded properly. Well, it's a welcome window, so just click on OK. You need to find your specific device here. You could do that in two ways. One by writing your microcontroller name, for example, STM32 F103C86. C8 is enough, it would find it. By click on it and download it, you have found it right now. And you could do it in an alternative way, and that is finding it by clicking on these options. Because I've searched for it before, it shows me where it is, but you may encounter a page like this when you open your pack installer. Keil has a strong support for ARM microcontrollers, and the companies that produce ARM microcontrollers, like Analog Devices, ARM itself, and Microchip, and Texas Instruments, and many other companies that produce ARM microcontrollers. But the microcontroller that we are using in this project is produced by ST Electronics. So we find it. The series that we're using is F1, F103. We click on it and we find C8. Again, we've found our specific microcontroller in an alternative way. If you want that download its pack properly and work with it, it's enough to download device specific packs completely and then you're ready to go. And other things are for specific functions and things and advanced stuff, and we don't need them in this project, in this simple LED blinking project. I have downloaded these packs before, device specific packs before, so I cannot click on them. But if I haven't installed them, and if you have not installed these packs, and the buttons here look something like this, you could click on it. It has written install on it, and when you click on it, it starts downloading it, and the progress is shown here. For example, I have not downloaded this pack for my Keil, so let's click on it. As you can see, the install buttons are ready for me, and I can click on them and start downloading them. So this is how you could download Keil packs for your specific microcontroller. Let's return to our settings options for target. And we discussed completely what these stuffs are. So let's go to target. Here you could specify which microcontroller you're going to use. Before the ARM compiler version 6 was released, I was using a compiler version 5. But when this version was released, I started using it. And I suggest you to use the latest version all the time. So we select it. In output, I usually check this create hex file because whenever I want to use STLink utility, I have this hex file ready to upload it to that software and then program my microcontroller. In listing in user, we don't need to do anything. In C++, you could specify your language. I usually use C99. It is a straightforward language, and you won't encounter strange errors when you compile your code. You could specify your optimization level 0, 1, 2, 3, and other things. I've chosen optimization level 3. If you're using external libraries in your program, you need to specify its path for the Keil, and Keil can find those libraries. Otherwise, you would encounter errors because Keil could not read those files. In order to include the path, you need to click on these three dots here in front of this include path, and it's a new and insert button. You click on it, and then you specify the location of those libraries, and then Keil would be able to find those libraries. In ASMN linker, there is nothing to do, and just leave them as default. In debug tab, make sure that you are
using STLink debugger and you're not using a simulator. And of course you could choose Ulink, JLink, and NULink and other debuggers that you're using, but here and in this case we're using STLink debugger. So make sure it is selected. Let's go to its settings. The port, serial wire. We're using a serial wire, not JTAG, so make sure it is on SW mode. And in trace, use everything as default. You don't need to change anything. It works properly without changing anything. And by default, when you upload the program on your microcontroller, you need to press the reset button on the board, and then your microcontroller starts running your program. Otherwise, it won't run it, and you have to press that button. If you want your microcontroller to run your program as soon as the code is uploaded on it, you have to check this reset and run. And if you want it to work properly, you need to come to pack and make sure that this enable option is unchecked. If it is checked, it won't work properly. Uncheck it when you have checked this reset and run. So make sure it is in this mode and enable is unchecked. So click on OK, and that's what we have to do here. And we're done with our settings in options for target.
Let's connect our microcontroller to our laptop. As you can see, the LED is on, so it means that sufficient power is provided for our microcontroller. By clicking on the download button here, I'm showing it by the cursor. I would upload the code to my microcontroller and see whether it works or not. So click on download, and yeah, here you see the LED connected to pin 30 is blinking. So let's change our delay tone. For example, change 500 to 100, changing the delays, compile it, and download it. Yeah, you can see that it is blinking pretty fast. There is just one more point that I would like to discuss here. If it is the first time that you're programming your microcontroller and you have clicked on the download button and your microcontroller doesn't start running your code, and in fact this LED which is connected to PC13 pin is not blinking, do not panic. I have to say that it's a common problem among beginners, and there's a solution for this problem. And the solution for this problem is all about this boot 0 pin. As you can see, it has written boot 0 upon this pin, and boot 1 blew it. For now, we don't have to do anything with boot as 1 pin, and all we need to do is related to boot 0. And this pin, like boot 1, has two states, 0 state and 1 state. If you want to program it, you have to put it on 1 mode, and then after programming it, you have to put it to 0 mode again. So let's imagine that we have encountered this problem. So let's put 0 to state 1. Well, as you can see right now, it is set to state 1. Boot 0 is now set to 1. Okay, so what you can see is still it is running our program. We don't want it. So we click the reset button. Now our microcontroller is in the uploading mode, in the programming mode. It is ready to get programmed. And right now it is not running our program. It is ready to get programmed. So we go to our software. I press download. Download is done, but yet it won't run our program. As I told you, we need to reset it to 0 again. So I reset it. Now, still it is not running our program, but after I press this reset button, you would see the LED starts blinking. Yep. And it is recommended by ST that you have to do this every time when you want to program your microcontroller. But after the first time, you don't need to set it to 1 and then program it and again reset it to 0. It works just fine. You have just to press the download button on the Keil software and it works just fine.